Okay, let's look at this. So what happens with this one is if I evaluate it, -1 to the n is just going to be -1 to the 1 for the first thing, and then I'm going to have -1 squared for the next thing, and then I'm going to get -1 cubed, and then -1 to the 4th. Okay, so obviously you see it's -1, then +1, then -1, then +1. Okay, so this gives a way that we can create an alternating series by just doing like -1 to a power. You can make it alternating or not alternating. But let's say instead of like this, I wanted it to go 1, -1, 1, -1, 1, -1. So I wanted to start with a positive value. And of course, if you want to do that, you could keep all of this the same, but you could just change it to this. Okay, so if I did this, then the first thing that's going to come out is -1. Now when I put n equals 1 in here, I'm actually going to get squared, right? And then I'm going to get -1 cubed, 1 to the 4th, -1 to the 5th. Okay, so that's just going to be 1 plus -1, right? Plus 1 plus -1. So again, you can play with like which one's negative or positive by either using like n or n plus 1. You can even use n minus 1 for the power. And if you play with this, you can get the alternating series to do exactly what you want it to do. Okay, let's look at a question like this one. Okay, so if we start evaluating this, now this is a lot of terms, but probably something's going to happen. Okay, so the first one would be looking at sine of pi, right? N is 1, and then we're going to add sine of 2 pi, and then n is 3, and then we're going to add sine of 3 pi. Well, let's just look at what the values of those things would be, right? Okay, so sine of pi, of course, you have to remember what sine looks like. Okay, it kind of looks like that. Okay, so at every multiple of pi, right, the value is actually 0. So this is like pi, 2 pi, right, 3 pi, 4 pi. So in fact, this whole summation of 100 things is going to be 100 zeros, so that whole sum is going to be 0. Okay, so let's look at this one. Okay, so for this one, we're looking at basically multiples of pi over 2, right? So it might be helpful to draw the sine graph again. Okay, so the first thing we're looking at, we plug in n equals 1. Okay, so n equals 1, I'm just getting the value. The first thing I get out of this is like sine of pi over 2, right? Okay, so that's just 1, right? The next thing I get out will be sine of pi times 2 over 2. That's going to be sine of pi. The next thing I get out is going to be sine of 3 pi over 2. Okay, so let's keep track of these values. So this is 1, right? Sine of pi over 2, sine of pi there, sine of 3 pi over 2, -1. Okay, and then let's see if we can do, the next one is going to be, it's going to run off the thing a little bit, sine of 2 pi, right? Because it's going to be, n is 4, right? So it's going to be 4 pi over 2, which reduces to 2 pi. Okay, so what happens is we get this pattern, right? Here, okay. So we get 1 plus 0 plus -1, 0. 1, 0, -1, 0. If you think about it, if we're just adding multiples of pi over 2 for each thing, each next term in the sequence, it's just going to repeat those 4 values over and over again. Okay, so the cool thing I notice is that this, of course, is designed to be like exactly a set of multiples of 4, right? So every 4 values, it's going to do, and then, it's going to repeat again. Okay, so hopefully you see that because it's exactly like multiple of 4 groups, that you're going to go through this whole cycle of things 9 times, but you know, every cycle of this, like this, those 4 values just add up to 0. So hopefully you see that basically because of the way they all like kind of cancel out and so forth, this whole sum, okay, is equal to 0. Okay, now let's say I adjusted that a little bit. I decided to do n equals 1 to 37, okay, of sine pi n over 2. Okay, if I did that, what's happening is I would do all of what I did above, which was 0. Okay, but I'd be adding in one more next term. Okay, so we'd add all of those things, but the one thing would come up next when I plug in, so you know, obviously the thing that is going to be 37 pi over 2, okay, would be the thing that wouldn't be included there. But if I think about it, like, so the last one I did was 36 pi over 2, which is 18 pi, which of course was 0. So this one will be 1. Okay, so basically this one is going to be, you know, a bunch of things, a bunch of 4-term things, which all add up to zeros, right? Because blocks of 4 are going to add to 0. And then the last thing I plug in, this thing, is just going to add a +1. Okay, so if I'm really asking you, you know, what this sum is of sine of, so the upshot for this series of numbers is going to be that that's equal to 1. Okay, let's look at one like this. Okay, so if you think about it, this one is actually an infinite geometric series. Okay, so what I can do for this one is go like n equals 1 to infinity, because I'm really adding all those things up. Okay, so let's see what's going to happen with this one. Okay, so I could do, hopefully you see that this will work, 1/4 to the n, right? I could test it out to make sure it works, right? So if I plug in n equals 1, I get 1/4. Plug in n equals 2, I do get 1/16, right? N equals 2, and then n equals 3, hopefully you see what happens. Okay, so I can see that the terms work out for this one, so that's how I can express it in sigma notation. Let's just do the added work of finding what this sum is, since we just practiced that already. So since it's an infinite geometric series with the ratio less than 1, remember you can do the first term over 1 minus the ratio. Okay, so what's that going to be? It's going to be 1/4, okay, over, I'm going to do 1 minus 1/4, because 1/4 is both the first term and the ratio. Okay, so I'm going to get 1/4, right, over 3/4, right, and then of course if I multiply by 4 over 4 for that, right, then I get 1/3. Okay, so in fact that whole sum is going to be 1/3. Okay, let's look at a sum like this one. So this one is the sum of the numbers from 176 to 200, if you think about it, okay? And so that's going to be arithmetic. So what you can do is use the summation form for an arithmetic series. Okay, so if you think about it, there's going to be 25 terms in that range of numbers. Okay, so again, what is the formula for this? It's 25 things. Okay, so you're going to do the first thing plus the 25th thing all over 2 times the number of terms. Okay, so what that's going to be is 176 plus 200 all over 2 and then times 25. So if you do all that arithmetic out correctly, you should get 4,700 for that sum.